The distance between any 2 points is some real number. But what distance doesn't tell us is the actual location of the point relative to each other. For example, this point has a distance of 5 from point 1. However, so does this point. If we were to consider all the potential points that are a distance of 5 from point 1, what do we get? We get a circle, where the distance from point 1 to any of the points on the circle is called the radius, and the only fixed point is the center. So we can see there must be some sort of relationship between the distance formula and the equation of a circle. Let's see if we can change the distance formula to fit the properties of a circle. First, let's change our circle to be an arbitrary circle. So, its center will be located at point HK, and any point on the circle itself will have a coordinate of x and y. Also, the radius will be denoted by lowercase r. So the first thing we can change in the distance formula is d to r. Next, although we don't know which point on the circle we are talking about, we do know that the center, or point 1, is always the same. This means we can plug in the points for point 1, which means x1, y1 becomes hk. And there we go, we have our standard formula for a circle. Note that by squaring both sides, you can also write the equation like this. Let's try some examples. For this question, we're trying to find the center and radius. So all we have to do is match the variables. Let's do another example. At first, you might think that the center is at 4, 1. However, notice how our definition for the circle has a negative sign in both parentheses. And in our example, we have 1 parentheses with the positive sign and 1 with the negative sign. So in order to correctly identify the center, we must turn this positive sign into a negative sign. We're going to do this by making this positive sign into 2 negative signs. We can do this since a negative times a negative is a positive. Now we can correctly identify the center as -4, 1. Let's think in reverse now. Find the standard equation of this circle. First, you should identify the radius. We do this by counting the number of steps it takes to get from the center of the circle to the edge of the circle. Next, identify the center. Now all we have to do is simply replace the variables. Here's one more. Let's talk about another way an equation of a circle can be expressed. It's called the general equation, which we can find by essentially expanding and rearranging the standard equation. The problem with this form is that it's harder to tell what the center and radius is immediately. In general, if you're given the equation of a circle in general form and asked to find the radius and center, you should first convert back to the standard equation and then find the radius and center. So the question that has to be asked is, how do we convert back to the standard equation? The key is a method called completing the square. If you have forgotten how to complete the square, there's a link in the description that will help jog your memory. Here are the steps to converting from general form to standard form. First, you want to group similar terms together. That means put all the x's together, all the y's together, and everything else on the other side of the equal sign. The second step is to complete the square for terms only with an x. Third, complete the square for terms only with a y. And lastly, step 4, find the radius r. Let's try an example. Find the center and radius. First step is to group similar terms together. So I put all the terms with an x together in parentheses and all things with y's together also in parentheses. Anything left over goes to the other side. Second step is to complete the square for the x terms. The coefficient of the x to the first power term is 4. That means to find the number we need to complete the square is 4 divided by 2 squared, which is 4. So I will put a 4 in the parentheses and 4 on the other side of the equal sign. Therefore, we've successfully completed the square. Third step is to complete the square for the y terms. Here the coefficient of the y to the first power term is minus 6. So the number we should add to both sides is minus 6 divided by 2 squared, which is 9. I add 9 to the inside of the parentheses and I add 9 to the other side of the equal sign. Therefore, we've successfully completed the square for our y terms. The last thing we need to do is solve for r. If r squared equals 36, then r equals 6. Notice how when we completed the square and solved for r, we only chose the positive results when taking the square root. Do you remember why? It's because we're talking about distance, which is always measured in positive units, right? Remember, we never say, I walked -3 miles today. It doesn't make any sense. Now our goal for this question is to find the center and radius. We already found the radius to be 6. All we have to do now is find the center. Let's match our results to the standard form of the equation of a circle. Again, at a quick glance, most students will say that the center is at 2, 3. However, this is not correct. Notice how h and k both have a negative sign in front of it, but in our results, we have a positive sign in one of the parentheses. In order to match the standard formula, we have to make that positive sign a negative. So we do a clever trick, which is to break that positive sign into 2 negative signs. Now it's much easier to identify the center as -2, 3. Let's do one last question. Step 1, group similar terms together and throw everything else on the other side. Step 2, complete the square for the x terms. The coefficient of the x to the first power is -4, so the number we should add to both sides is 4, resulting in a square of x minus 2 squared. Step 3, complete the square for the y terms. Since 8 is the coefficient of the y to the first power term, then the number we should add to both sides is 16, resulting in y plus 4 squared. Step 4, find r, the radius. If r squared equals 9, then r equals 3. Remember, always the positive case. And when we look to find the center of the circle, we must first make sure the inside of both parentheses have negative signs in order to correctly identify them. Then we see that the center is at 2 minus 4.